Hello and welcome to the BMC Learning Series. Today we'll be covering MainView Advanced Architecture Part 2. Note, if you have not already completed MainView Basics, please do that first. One of the strengths of MainView is its flexibility to adapt to the user's needs and do so without modification of code or complex files like XML. MainView customization is done using interactive dialogues to simplify the process of customizing MainView. In this section, we'll discuss view customization and the many capabilities therein. We'll also cover building custom contexts, a great tool for environments with a large number of target systems and subsystems. We'll finish this section by looking at customizing workloads. Note that there are a couple of brief quizzes along the way. Just use pause to take your time to consider the questions before the answers are displayed a few seconds later. The View Customization dialog is opened by issuing the cust command on the command line for the active view. The first view customization option we'll cover is Show and Hide Excluded Fields. This is the option E on the right. The excluded fields are shown with the yellow column headings, indicated they are currently being excluded from the view. Notice option E now shows Hide Excluded, not Show Excluded. Option E acts as a toggle whether to display these fields or not in the customization dialog. Displaying the excluded fields can be useful in identifying additional fields to include in a view or to set filters on fields not normally displayed in a view. We can easily add and remove fields from a view's display. The fields are still there and can be added at a later time. To add a field to a view, first identify the field you wish to add. If we scroll right, we can see additional fields we may want to include in the view. In this case, we're going to include the total delay percentage, which is identified as column Z. To include this column, we enter the Include option I, followed by the column we want to include, Z. So we enter IZ on the command line. Notice the column label for the total delay is now light blue. This indicates the field is now displayed in the view. In addition, you could use the Exclude option X to hide fields in a view. To exclude the column we just added, column Z, we would issue the command XZ and the column label would turn back to yellow. Now that we've added the total delay column to the view, let's move it to the left next to the job field name. To do so, we can use the Move option, M. The format is MZA to move column Z after column A. And now the total delay is presented as the next field following the job name. Notice that the column label is changed from B to Z. The column letters are always maintained in sequence and are specific to the View Customization dialog. Now we can format the total delay field to modify the heading. To do so, we can use the Format option F. To change the format of column B, we enter FB. We'll increase the field width from 5 to 6 and expand the Heading To label to say Delay Percentage instead of DLY percentage. And when Enter is pressed, the field is updated. There are several other customization options in the format display. You can indicate that you want a field displayed as a bar graph or hexadecimal value. You can say whether or not you want to show zeros instead of blanks for zero values. If you are working with a summarized view, you have several options for displaying the data in a field. We'll discuss those options when we discuss summarization a little bit later. If we wish to sort the view and preserve the sequencing when it's redisplayed, we can use the View Customization Order option, O. Unlike the Sort command, the Order option is saved in the view definition, so it provides a persistent change to the data sequence. Let's reorder the view by the total delay column. We can do so by issuing OB to order the view by column B. By default, the sequence is descending, but it can be changed to ascending by changing the D to an A. You can also add additional levels of sort by referencing the appropriate columns. If we wish to filter our view to show only jobs that start with S, we can do so quite easily by using the filter option L. To set a filter on the total delay column, we enter LB on the command line and press Enter. In the Filter Condition field, we specify equals S star for any job names that start with S. We can also assign this element as a positional parameter, which can be passed when invoking a view. This may be helpful if you find yourself setting filters on the same fields repeatedly. We can also quite easily modify the thresholds for a field. Thresholds determine the display properties for values in a field. Let's modify the thresholds for the total delay field, which is in column B. To access the thresholds dialog, we enter TB. There are several input fields presented. On the left, we specify the various conditions that determine what attribute to apply to the field. The attribute fields, ATTR, in the center of the dialog indicate the coloring for the values when the corresponding condition is true. On the right is a legend of the various attributes for reference. We can modify the thresholds by overtyping the values in the condition and attribute fields. It's also possible to add and remove thresholds. Once we're satisfied with our changes, we press Enter and the view is updated. Be sure to specify your most restrictive conditions first in the list, as MainView will evaluate the conditions top-down. For example, if you specify the first condition in the scenario as b greater than equal to 0, none of the other conditions would ever be evaluated because the value would always be equal to or greater than 0. At the top of the center pane in the dialog, there's a field labeled Inherit From. This option allows specification of a different column to use to determine the attributes for the values in this field. This might be useful to you if you want to turn an entire record red if a critical threshold is reached for a particular field, for instance. There's also a field that allows you to specify whether or not to use dynamic thresholds if they're available for this element. In some cases, it's useful to repeat a field to do things like create a bar graph or add values to a summarized view. To repeat a field, we use the Repeat option, R. Let's repeat column B so we can create a bar graph for this value. Enter R, B, and press Enter. Now column C has been added to the view, which has the same value as column B. It just shows it a little differently. By default, the new field is expressed as a bar graph. Now we'll want to modify the thresholds for this field, so we can use the Thresholds option and issue TC, then press Enter. On the Thresholds option display, we're not going to specify any conditions. Instead, we're going to inherit the thresholds from the Total Delay field, column B. To do so, we type B into the Inherit From field. When Enter is pressed, the values in column C are updated with the threshold attributes for column B. The Parameters option P is used to display existing positional parameters and specify complex filters via where and QWhere clauses. Where and QWhere allow many operations not supported for simple filters. There'll be more discussion on where clauses later in this session. A powerful feature of the MainView infrastructure is the ability to summarize view data. This is sometimes referred to as group by. The summarization option is Z. Summarization tells MainView to group all the records together with unique values in the targeted field. For instance, we want to summarize our view by service class, so we have one record for each occurrence of a unique value in the service class field. To do so, we enter ZD on the command line. And notice that when we summarized the service class field, it became the first field in our view. When we summarize our view by service class, the job name field now displays the best fit mask for the records summarized. This is not of much value, so we can format the field to provide more meaningful value. To format column B, enter FB on the command line. In this instance, we're going to change the job name field to show a count of the number of address spaces, or jobs, included in that summarized record. To do so, we update the field width to 2 bytes and change the heading 1 and heading 2 fields for our new label, #AS. Then, over on the right, we need to change the summarization type to C for count. When we press Enter, the view is updated. Once we've completed all desired customization to a view, press P(F)3 to exit the customization dialog, and you'll be prompted to save the view and provide a name. Regardless of whether you save the view or not, the view currently displayed will continue to show the customization until the view is redisplayed. This is a good time to discuss the various summarization types found in the View Customization Format option. The Sum summarization type will total all the values for a field in the summarized record. Sometimes this can be helpful, reporting total CPU used, for example. The Average summarization type displays an average of all the values for a field in the summarized record. This is the default behavior for numeric data. The Percent summarization type displays what percentage of the whole the summarized record has for this value against the total for all summarized records. Using the Minimum summarization type will display the lowest value found in any of the summarized records. In addition, using the Maximize summarization type, this will display the highest value for the field in the summarized records. The Count summarization type displays a count of records summarized. The records to be included can contain a simple filter argument to limit the count to a subset of the summarized records. The Any summarization type is used for literal fields and displays a best fit mask for the values in the summarized fields. If you don't remember what these different summarization types are, you can always use P(F)1 with your cursor in the field for an explanation of these values. The BBS-def file contains the MainView screen definitions. The BBV-def file contains the MainView view definitions. When a view or screen is saved, it is written to the first dataset in the file concatenation. The allocation of user-level libraries is determined during product customization. Users will be prompted to allocate their user-level libraries each time they start a MainView session until they allocate these libraries. Views and screens are displayed from the first hit in the concatenation. To share summarized views and screens, you can copy the PDS members in the BBVDef and BBSDef files. Okay, here's a quiz. Pause here before the answers are displayed in a few seconds. Context is a very important concept in the MainView infrastructure. Context determines which targets are eligible to provide data to a view. MainView provides some default context for your use. There's a context definition for each individual target, such as an MQ, Queue Manager, or a DB2 subsystem. There's a default context of all that provides data from all the available targets. There's also the context CurSys that includes only targets on the current ZOS system. This context is especially useful for alarms. Custom context can be defined within the Plex Manager component of the MainView infrastructure. The Plex Manager is accessible from the primary MainView menu, Option P. When you first enter the Plex Manager, you'll be presented with a menu Easy Plex. To view the currently available context definitions, you can hyperlink on one of the entries on the left under SSI Context Activity. To add a new context definition, we'll hyperlink on the context definition item in the center of the menu. When we first enter the context definition view, ConDef, we're presented with a display of all the defined contexts. From the ConDef view, we can take many actions related to the context definitions. Here we can add, delete, copy, modify, and deploy context definitions. If you P(F)1 in the first field next to the records, you'll get a list of the available actions. But before we can do any of those things, we must first get a lock on the definitions list. We do so by entering Edit on the command line, and the window information line now shows Edit. Only one session can be edited in the context definitions at a time, so be sure to release the lock by exiting the ConDef view when you've finished your work. To add a new context definition, we type Add on the command line and press Enter. And we're presented with the Add New Context Definition panel. First thing we do is give our context a name. This is a value that would be referenced in your context commands. Specify a brief description of the context in the description field. At the bottom of the display is a legend of substitution parameters for the referenced values. In the middle of the display, we enter our inclusion filters to identify which targets are to be included in this context. In this case, we're building a custom context for MainView for kicks that will include any kicks region that fits the mask C plus GM or C plus GAA star, where the plus represents a single character and the star is a wildcard. Up to 8 different filters can be defined. Once you're satisfied with your new context definition, press F3 to save your changes. The Edit on the Windows information line now shows Edit Mod to reflect the changes that have been made while in edit mode. At this point, let's save our context definitions by entering Save on the command line. Then you'll be prompted to update the context description and F3 to save the definition. Notice the Edit Mod is changed back to Edit. That's because there's no difference between the saved copy of the definitions and the working definitions in your session. Now that we've saved our definition, we need to install a new definition list. To do so, we type Install on the command line and press Enter. Once we've installed the context definition, it's ready for use. In this instance, we'll use it via the set command. Notice that we've specified our new context, Jeff Kicks, in the context field. When the fields are all set to the desired values, press F3, and the new context is displayed in the targeted view. Custom context can bring significant value to an enterprise, particularly those with a large number of targets. Okay, time for another quiz. In addition to custom context, with the MainView infrastructure, you can also define custom workloads. Unlike custom context, workload definitions are created within the various MainView solutions, not the Plex Manager. This makes the workloads specific to particular environments. The process for creating workloads is very similar to that of creating contexts, however. Custom workloads allow you to aggregate or segregate workloads in a way that makes sense for your environment. By default, MainView will have definitions for all your WLM workloads and classes. To define workloads for Kicks, DB2, and IMS, we use the same mechanism. MainView for ZOS has a slightly different interface. Let's create a new workload for Kicks. Kicks workloads are defined in the CWK LD def view. As with context definitions, you must obtain an edit lock on the definition list before you can make any modifications. Type Edit on the command line, and the Windows information line should show Edit to indicate that your lock is active. To add a workload, we type Add on the command line and press Enter. And we're presented with an Add a Workload display. Here we can define our workload name and performance goals. In this instance, I'm going to create a workload named Jeff Kicks with a response goal of 1 second for 90% of the workload. If we scroll down, we can qualify our workload. Here we can specify which transactions to include or exclude from our workload. Workloads can also be qualified by transaction class, program names, terminals, or user IDs. Once we're satisfied with our specifications, press F3 to save the workload definition. We're then returned to the workload definition list. We need to save the definitions to a file, so type Save on the command line and press Enter. Next, it's necessary to install the workload definition so it's made available. We can install our new definition, Kicks Jeff, using the install line command, INS. Once our workload is installed, we can view it in any workload-oriented view, such as the Kicks Objectives views, COBJ. Okay, one more quiz. Hyperlinks are point-and-shoot constructs in the MainView architecture. The idea is to put your cursor on a value in a view and press Enter to navigate to additional detail regarding the value you linked from. Hyperlinks can be context sensitive. They can be different for different values. Hyperlinks can transfer between MainView monitors. Fields with hyperlinks have highlighted field headings, white by default in the 3270, teal in the Explorer. Hyperlinks can be added to columns, or existing hyperlinks can be modified. This is accomplished via the View Customization dialog. Hyperlinks consist of one or more MainView commands separated by semicolons. Hyperlink definitions can reference fields in the source view by column header. The references to fields on the target view use element or variable names. Be aware that hyperlinks may be conditional. In these cases, there may be multiple hyperlinks defined for a field. To define or modify a hyperlink, you need to start the View Customization dialog by issuing the cust command. In this case, we're going to set a hyperlink on the Unix process ID field to transfer our session to MainView for Java environments for details about the JVM. To do this, we enter HN to open the hyperlink fields in the center of the display. And here's the hyperlink. It may seem a little complex, but it's not if you separate it into parts. Remember, the hyperlinks consist of one or more commands delimited by semicolons. In this instance, we have three commands. We have a context command, con all mvje. This command sets a context of all the JVMs in the MainView for Java environment solution. The second command is a view name, JVM disk. This is the MainView for Java environments view that will display the JVM details. The final command is a where clause. In this case, we're setting the variable PID in the JVM disk view to the value in the column N of the source view, in this case, the Unix process ID. Left of the commands is a condition field. The condition field can be used to apply hyperlinks to a field on the basis of some filter value. Customizing hyperlinks can improve your time to problem resolution by directing the defined MainView hyperlinks to views that make the most sense in your environment. That concludes this session on MainView Advanced Architecture Part 2. For more videos on MainView and other BMC solutions, please visit our BMC Mainframe YouTube channel at youtube.com/user/BMC Software Mainframe/featured. That's it for now. Thanks again, and we'll see you next time.